Okay, let's get started. Hi, everyone. Welcome. We are going to be diving deep with MetaHumans today. My name is Alex Coulomb. Some of you saw me speaking yesterday, much more generally about a lot of different things related to Unreal Engine, and this is going to be a little bit more focused. So who am I? For anyone who doesn't know, Alex Coulomb. You can find me on most social media as iBrews, IBREWS. I run a XR creative studio in New York City called Agile Lens Immersive Design. I also have the only and best authorized training center for Unreal Engine in all of Manhattan, which you can find at alexcoulombpresents.com. By the way, quite a few people asked me yesterday, when will part 2 of that talk happen? It will be through my training center, so probably a little bit after yesterday's talk gets posted to YouTube. Like a week later, we'll do a big giant Zoom session, and we'll go through the next hour or 2 hours of more general tips and tricks. Other couple things about me, I'll be helping out with the Unreal Engine Games Fellowship coming up. I co-host a podcast called the Unofficial Unreal Engine Podcast, and we talk about all sorts of fun things related to Unreal Engine whenever we find time to do that. And I like all things VR, emerging tech, architecture, theater. I'm all over the place with this stuff. So I'm going to try to talk a little slower today compared to yesterday. We'll see how it goes. There's a little bit of stuff in here. I thought I'd start with some of the examples of my company and what we've done with MetaHumans over time. So we do an annual production of Christmas Carol that has used a variety of different capture methods. We've done stuff with MetaHuman Animator. We've done stuff that was live from within VR. This is using Meta's Movement SDK. We've done stuff with AI, in-world AI, and Conv AI. This is our Christmas Carol production, so sometimes we have some pre-rendered things. This is Body of Mine, just came out on the Quest store last week. Check it out. It's about gender dysphoria. This is a live show we did with NYU last week in front of an LED volume. More Christmas Carol stuff, dancing. This was the very first MetaHuman test we ever did with Xsense suits and Technoprops helmets. And this is Performer, which is what we made at the Meta XR Hackathon a while ago. And there's Marley being real angry. This feels so terrifying in VR, by the way, to have a ghoul screaming at you like that. So very quick introduction just to some of the stuff we've gotten up to with MetaHumans. So you're like, does this guy actually know anything? I know a little bit. I'm not going to say I speak for Epic or anything on any of this. And by the way, caveat, I do stuff with Epic. I created a lot of courses for them, including MetaHumans, but nothing that you're seeing here today is like official Epic. This is just Alex of Agile Lens in New York City saying the things that has been useful to me and my company over the past few years. So I'm going to assume most of you have done something with MetaHumans before. This is very much an intermediate level class. I'm not going to explain what MetaHumans are. I will briefly just review with you all for anyone who hasn't touched them in a while. We have MetaHuman Creator, where you can go onto the internet, and of course, using wonderful pixel streaming technology, you can create whatever kind of MetaHuman you want. One update I want to give to this, some of you might not know, that as of 5.4, there's a new little thing that I'm quite happy about. What does anyone think about if you see this symbol and you're thinking about MetaHuman Creator? You can just shout it out. Yeah, hair, exactly. So a lot of incompatible grooms, especially if you're using hair cards. So you'd end up in this situation where you're very close to your MetaHuman and it looks great, and then you zoom out and they're balding very, very fast, and it's sad, and this is all gone now. If you go through all the grooms in MetaHuman Creator now, you will find that every single one of them now has hair cards, and also quite a few of the previous hair cards have been improved. And if you toggle between the grooms, which of course are much more expensive, and the hair cards, which are much, much cheaper to render, you'll actually find there's just an overall improvement in quality, and there are no caution symbols to be found there. So that is great news, and you can make your characters look however you want and not worry about how it'll perform on different platforms. Mesh to MetaHuman is something that I think is getting a little less attention now because MetaHuman Animator kind of took over the conversation, but it's still an incredibly useful way to take any kind of 3D model of a humanoid face and turn it into a MetaHuman. So you can take something created in another program, even just something modeled completely without bones, and then bring it, of course, into a system where you're using all the blend shapes and skeletal data of MetaHumans, and then they can animate along with everything else. Because, of course, one of the best things about MetaHumans is they all have the same core skeletons. I remember years ago when I needed to animate an entire room full of audience members, and they all needed to have similar, yay and whoa and let's do the wave. But to actually retarget the animations needed to all those different to all the different skeletons was a bit of a nightmare. So MetaHumans is already incredible just because of the fact that everything retargets to everything else. So Mesh to MetaHuman is great if you need something that is going to be still humanoid, still MetaHuman-esque, but you don't necessarily want to deal with like all the complexity of using MetaHuman DNA and going over into Maya and dealing with all sorts of complicated scripts to modify the core functionality there. It does still need to be humanoid. The biggest thing to be careful of is the eyes. As much as you might want to make like a very stylized character with giant eyes, like an anime style sort of thing, you're not going to be able to do anything with eyes at different sizes unless you actually then go over into Maya, for example, and do some pretty complex modification of how that's going to work. But you can do all sorts of crazy fun shapes. You can see a few examples of what I've played with over there, and they work well. Also, whenever you upload anything with Mesh to MetaHuman, pardon me, and this applies to MetaHuman Animator as well, the one different part you'll see in MetaHuman Creator is this overall influence slider, which lets you basically decide like how much do I want it to match the mesh I had. And if you see clipping, if the eyeball is kind of going through the eyelid or the teeth are going through the mouth, you can do this either at a global level or for each region. And it's a really handy way to decide like, do I want the eyebrow to be doing that or do I want to like tone it down a bit? You have that option at any time. And then briefly, just because I like to review with people how to go about using Mesh to MetaHuman, you would want to sculpt your character in any program you like. Sometimes I'll just hop on Sketchfab and download some, random free ones with all the licensing and start to play with them. You create a MetaHuman identity. This is a lot like MetaHuman Animator, of course. And then you set up where the eyes and the eyebrows and the mouth are. And ideally, you do this from multiple angles. And then you track all that. You run your identity solve. You have to pick a body in order for it to be uploaded to the MetaHuman Creator library, and you can auto-rig it. You do have the option of just doing the skeletal mesh right there locally, but it's actually quite nice to be able to have all the features of MetaHuman Creator available to you, even with a particularly stylized character. And then eventually, you will also see it over in Bridge, and you can download it however you want. Okay, MetaHuman Animator, this is one we've been having a ton of fun with at my company. It, of course, allows you to get very high quality animation for the face just using your phone. It uses a depth sensor. I believe last time I checked, iPhone 12 was still the best phone to actually do capture with compared to even the newer iPhones. And I have both, so I've done some back and forth, and I have seen better quality with the 12. And unlike when you're using regular Live Link Face, which is just entirely RGB based and trying to get face data from that, MetaHuman Animator is able to use the depth data and actually go through kind of a machine learning process to get higher quality looks. And that's particularly nice because of the fact that first of all, the downside is it's not live. We've used, the ARKit face stuff for Live Link Face for, live theater shows. For MetaHuman Animator, it does need to go through and process, so it's not a real-time workflow. But once everything's processed, of course, you can play it back in Sequencer. So I'm going to try to do like a really quick flyby of like the basics of MetaHuman Animator, and then we'll slow things down a little bit. But for anyone who wants to hear like in 1 minute exactly how you'd actually go about the whole MetaHuman Animator process, buckle up. Okay, so to get started with MetaHuman Animator, you open an Unreal Engine project, obviously, and I really like the MetaHuman lighting sample, which has all sorts of great lighting setups. And once it's open, you're going to enable the MetaHuman plugin, and you restart. Meanwhile, you're capturing things with your iPhone. You use the MetaHuman Animator app. Make sure you're in a well-lit full view, but you're going to need to look gray in the depth test. That's how you know things are good. And then you get to calibrate your identity, take where you look left, right, neutral, and then you show your teeth. And from there, you're going to record whatever you want, and you can share all that footage with your computer directly, or you can grab it using Live Link, even though it won't look like it's a Live Link connection, but it still is working. And then you create a new capture source. You open the capture manager to process it all. And then next, you're going to end up creating a MetaHuman identity file where you snap the front, left, right, and then eventually, of course, teeth poses and go right down the line in the toolbar processing everything. Feel free to crank up your cache if your computer's struggling at all. Note that you can process this identity just locally or make a complete MetaHuman like I showed earlier. Then you can continue to work in the cloud using MetaHuman Creator. Be careful if you have a slow computer because you'll get shamed for it, but it'll still work. Once you have a successful MetaHuman identity profile, you're good to go building the MetaHuman performance, where you select a take, then the identity, then you process it all using the amazing machine learning, and you even get the tongue, which is pretty impressive. Look at that tongue. You can then export these takes as level sequences using the control rig and a nice overlay of the person footage, or you can export animations. Be sure to get a full MetaHuman into your project and use a MetaHuman skeleton face archetype as the target. If you want this to work with all your MetaHumans, then they can all sing together and have a nice kumbaya, and you are done. It's very easy, as you can see. Okay. That's the whole tutorial, yeah. Cool. And something I'd love to talk more about, that there's actually some really good existing talks on it, is the DNA calibration library, where you can actually go much more in detail about moving around exactly how the face is set up. And again, you can get much more stylized with things like the eyes. There is a GitHub project, if you just Google MetaHuman DNA calibration, that helps walk you through setting up those more advanced features for modifying your MetaHumans. Briefly, I wanted to mention with Quixel Bridge that when you are downloading the stock MetaHumans, you end up with only the highest quality available. I'm not quite sure why that is. If you're doing custom MetaHumans, you actually have opportunities to do low, medium, or high quality, which of course are going to have different texture sizes, different mesh resolutions, things like that. So oftentimes, of course, because I'm targeting mobile platforms and VR, I will often start with low quality MetaHumans, which look quite nice. Not quite as nice as the UEFN MetaHumans, which unfortunately still haven't come over to Unreal Engine. We have these like 70 megabyte, very good looking MetaHumans for Fortnite, and still most MetaHumans in Unreal are like 1.7 gigabytes. But this is a good start, just for having something that's a little more optimized and is still going to look quite nice. Now, one of the first things I'll do when I bring MetaHumans into my project is consider texture reduction. So, I bet you guys are all pretty smart. I'm pretty sure you can tell which of these has a much higher resolution set of textures. But if you compare, the close-up at kind of the lip level, where you still have the grooms, all the little facial hairs are still there, versus something that's a little further away, on the left, you can kind of tell a little lower resolution. On the right, even from this distance, it's not as obvious. And so, this is a 10x difference in size. We have about 120 megabytes of textures versus about 1.2 gigabytes. So it's something to consider. And if you want an easy way to actually reduce your textures, I did mention yesterday a batch process for just telling Unreal to output lower resolution textures. But if you're like, I've got a project with 50 MetaHumans in it and it's 2,000 gigabytes, whatever, and you actually are trying to get your project size to be smaller, textures are a great place to start. So I would recommend, for example, that when you go through here and you're looking at, all the textures you have, that you find your character, open it up, and then you can filter by textures. So this is very similar to what I was showing yesterday so far. Get columns, find everything that's above the dimensions you're comfortable with. So we see a bunch of 8K textures here. And so I might say, for example, for this project, I don't need anything above 2K. Again, maybe targeting mobile platforms. So I'd select all the way down to the end of 4K there, and then I'd go to Asset Actions and use the bulk export, not edit selection in property matrix. Then I would just find a place to output it, in this case, just a desktop. And I do want to make sure that everything is exporting correctly. So it's always good to keep a copy of these, especially if you're not using source control, but you should use source control. So this actually exports much slower than what you're seeing here. It took a few minutes. Then an easy way to batch convert textures is a free program called UEFN View. And so in this case, what I'm doing is I'm taking all the textures that output with all their subdirectories. This is important because it's going to make your life a lot easier. So I'm just adding in using that include subfolders for add all. So I'm bringing in everything that is game, which of course is a synonym for the content folder. And then I'm going in here, and it used to be TGA. Now it seems like Unreal likes to export PNG. So just for the sake of apples to apples, I leave it as PNG, and then I do a resize, keeping everything to 2048 by 2048. So they're all shrinking from 8K, 4K, whatever the case may be, down to that. And this is an important checkbox: create subfolders in destination folder. So now what's going to happen was when I start this batch and I've got like a little output folder to put them in, you'll see that it kind of processes through this. And again, I'm speeding up time here. Going 8K to 2K is not this quick. But you'll see that they're doing all the subdirectories for where all they go for the MetaHumans. And of course, there's the common folder. And all you have to do once you're done is drag that MetaHumans folder right into the content folder. And it does, bloop, everything's updated, and you're done. So it's a very quick way, and you can see everything with an asterisk is the things that have changed, and now we have nothing in our project that's above 2K. So just a useful way to significantly bring down your project size if you know you're never going to be targeting particularly heavy platforms. And you can see they still look good, especially at this distance. And just for the size comparison, so here we have, the 121 megabytes of the output versions, and then there's the 1.2 gigabytes of the original versions. So you would, if that quality loss is acceptable to you and you like having your project be 1/10 of the size it was, it's not a bad workflow. And so again, just to compare a little bit closer up, before, after, before, after. Okay, let's talk a little bit about animation with MetaHumans. First of all, simplest way to get simplest way to get a MetaHuman to play an animation is to click on the body in its blueprint component section, and you can change this to, this will usually be a blueprint asset. Instead of blueprint, just choose an animation asset, and then you can just click an animation. And by the way, we're going to talk about retargeting, but if you just have some mannequin animations or even something that came from Mixamo or somewhere else, there's a drop down here, and you can hit a checkbox for show or allow incompatible skeletons. We have a slide about that later as well. But you can also just see, like, hey, does this non-retargeted animation work okay? And you can even see it playing right there in the game. One other thing to be cognizant of is if you're going into sequencer, by default, every time when you drag a MetaHuman into sequencer, it gives you all the control rig setups, which are great if you're going to do keyframe animation there. But anytime you have animations that are ready to go, you do need to delete those or the animations are not going to work properly. And then you can just go and find whatever animations you want to add and scrub back and forth and see them all working. If you have an animation that you want to be root motion based, like a walking animation or something like that, but the animation you have is one that actually does progress over distance, here's a quick way to grab these animations. And in my case, it was jogging animations and walking animations. And I'm using that bulk edit via property matrix tip from yesterday and going through and doing a root motion root lock on the first frame. And then that basically forces them to now jog in place. So that's handy. Randomization. So this is something I do in my MetaHumans course. That you can read a little bit more about that at unrealengine.com/training. And as part of this, I show people how to build a MetaHuman randomizer, basically by importing a bunch of MetaHumans and then allowing for them all to share the same assets. Because even though there is not a parent MetaHuman, you actually can take all the assets that are similar across MetaHumans and use them together. I also have a bunch of animations that I play with. So in this case, an animation montage allows a big array of different animations to play at different play rates and start at different times and have different speeds. And it actually looks quite nice if you're trying to do a bit of a crowd simulation. So basically every time my crowd simulation starts, all of these start playing, and obviously we could have a different set of animations than this, but it's a fun little example for a short class. And then, for everything else, like the hair, for example, you just have an array of your different grooms. Also, the binding assets need to match. You need, Afro Curly, you need Bob Curly, all to be in the same order. And then in this case, I'm just getting a random integer and then selecting, that for each one and putting that on the character randomly. You can also play with changing hair color and skin color and things like that if you want to as well. And so here's a little bit of what it looks like with the blueprint. We've got a little button we can call in the editor to just kind of cycle through different options. The colors are totally random, so those end up being pretty funky, but there's some fun things you can do to play with that. And then here they are just having a good time, like you do as a random MetaHuman. And so, you end up with like some weird proportions sometimes. I do recommend, by the way, one slide I meant to have is if you're ever doing a child MetaHuman, play in MetaHuman Creator with the slider for the head size, because typically if you just make the head particularly large and then you scale down the whole MetaHuman, it actually can read as a child. Playing animation in editor, if you do actually want to see this all playing back, there's actually a node called set update animation in editor, which for some reason is disabled by default with MetaHumans. You can hit the checkbox for this for mannequins and it'll work fine. In this case, you need to call it in editor, which is the little function symbol to the left there. And you can basically have a button to say, hey, I want my MetaHumans to be able to play back their body animation while in editor. Now, this is what I was doing for older versions of MetaHumans. As of 5.3 and 5.4, there's this nice new little graph that actually allows this to happen at the base MetaHuman level, unless you are trying to do face animation. As far as I know, there's not any way to have face animation playing back in the editor using the default MetaHuman setup, unless you're doing live link face. So it's fine, that connects fine to the editor. There's a checkbox for use ARKit face and it'll activate immediately. But if you're trying to play back an existing animation like the one that I have right here, this is being done with that node of play montage. So I'm basically saying once everything is kind of activated for the body, let's also play this montage, and that will also happen in the editor. It basically overwrites the live link face setup. Okay, let's talk a bit about optimization. Again, this project we had that just came out last week called Body of Mine was a significant lift to be able to make lots of MetaHumans working on not just the MetaQuest 3, but also the MetaQuest Pro and the MetaQuest 2. And we needed the MetaHumans there to run at 120 frames per second. And so it was fun. First of all, of course, for anyone who hasn't played with zooming in and out of MetaHumans, you have different levels of detail. By default, I believe there are 8 of them. Yes, number of LODs, 8. And so you actually have a component in MetaHumans called LOD sync. And it's actually quite nice because instead of leaving each of the different meshes to decide on their own when to jump to different LODs, you can coordinate it. So you can say, across these 8 levels of detail, because base 0 with arrays and all that, you can say, stay at LOD 0 for these 2, then go to 1, then go to 2, then go to 3. In other words, not every part of a MetaHuman has 8 LODs, and you can kind of coordinate how this is changing, and you can modify it. If you're like, you know what, I really can't see the difference between LOD 0 and LOD 1, and LOD 0 is much more expensive, I could change both of these to 1, and then we'd actually be totally fine. So if you are trying to limit this and you say, I don't want to have all 8 LODs, in the case of Body of Mine, we actually were trying to reduce this significantly to, I think we ended up trying to do 2. You would think that for the LOD sync component, you would go, sorry, this is the default first. So the default is 8 LODs, forced LOD -1, which basically means, hey, Unreal, I trust you. Just pick whatever LOD makes sense. And the minimum LOD is 0. So that's the highest quality LOD possible. So in this case, when I'm very close, everything being white and black, that tells me it's LOD 0. And then zooming out here, we're at LOD 3. And you see different colors representing the hands or the body, the torso, the face, actually operating at different LODs based on the LOD sync component. So if you wanted to say, I just want to use LOD 3, it's the one that has the best quality, we're never getting much further away than the character for this particular VR experience, then this was my instinct of how I thought this should work. I thought I'd need to say, I only want 1 LOD, I want it to be LOD 3, and I want the minimum one to be 3 as well. You would think that would work. However, when I tried that, I found out that for some reason, it was still holding everything at LOD 0, except for the hands. No idea why, but the hands would actually change to LOD 3. Not quite what I wanted. We're mostly looking at the face, not the hands. So it turned out that if you want to force an LOD like this, the way the LOD sync tool gets set up is a little bit different. You actually want to say, for the number of LODs, in this case, 4, you'll see why in a second. Still, yes, force the LOD to be 3, and you want the minimum LOD to also be 3. So just to compare what I had, 133 versus 433. So the number of LODs in this case was the deciding factor. So to think of this as a bit of a math equation, you actually want to have, n equals the LOD you're chasing, and then the number of LODs, it's actually how many LODs you need to be able to get to. So it's not just that we want to say, I want 1 LOD because I only want LOD 3. You actually need to get to LOD 3. So that means LOD 0, LOD 1, LOD 2, LOD 3. So there's 4 to get there. So that was something that was very confusing to me about the LOD sync component for a while. And I hope that helps you if you're trying to have fewer MetaHumans or fewer versions of MetaHumans in your scene. Now, if you wanted a bit of a range, because this is also what we did, we said, okay, we're only going to use LOD 4 to LOD 6, for example. So that's a little bit different as well. So in this case, this is what we see if we have number of LOD 7. We're still letting Unreal Engine decide using -1. And then we're saying start at number 4. So don't use LOD 1, 2, or 3. Go to 4. And then we have this kind of, cascading set of changes. And you'll notice like the torso stays the same for the first 3, changes as we get farther and farther away. So the math for this one is you want to say the worst LOD that you want. So LOD, let's say 3 in this case. And then +1. Or I'm sorry, the worst one would be the farthest one. So the worst one, of course, is 8, and then you want to go +1 above that. So we thought the LOD 8 actually looked pretty bad, so we didn't want that to show up at all. So that's why here we have the number of LODs being 7. So we're discarding the final one. We're still okay with 7 showing up. And then forced LOD, so we're still letting Unreal Engine decide which one to use. And then for the minimum LOD, we pick the one that we're most comfortable with. Even 3 in some cases was a little bit too heavy. So in some cases, we did the minimum LOD as 4. Okay, so then with the LED sync component as well, you do have the ability, of course, to go in here and start to change these. This is useful too if you're finding that as you get farther away from something, it isn't quite matching the LEDs that you were expecting. And so we have a few different places we can change this. Of course, we can do it in the LED sync component. We can open up something like the individual meshes. We can do things like change the individual minimum LEDs there. But we also have a whole asset called LED settings. So there's all these different levels of complexity for how much you want to go into specifying exactly how you're going to be streaming your LEDs. And we have max number of streamed LEDs, max number of optional LEDs. So as you can see, this could be an entire hour talk on itself. But just trying to point you in the direction for really fine-tuning exactly how your LEDs work if you want to. One other thing here, of course, is using hair cards. It's great because if you don't need realistic physics, if you don't need to see all the individual hairs, if you're targeting lower-end platforms, you definitely want to be using hair cards because they are kind of like the output we just saw. They're like roughly 1/10 the cost of grooms in most cases. And again, they've gotten a lot better. In some cases, we've found that the hair cards can be a little bit they can work in kind of an unexpected way sometimes. They might detach from the head. They might lag behind the head sometimes. I'm sure there was a more official way to address this. What we found was useful for Body of Mine, at least in some cases, was not actually using a groom asset with hair cards, but literally finding a particular LOD of a hair card that we were okay with, and then assigning it to our character as a static mesh, and then just binding it to the head bone. So that's probably not something Epic would recommend you do, but it was a good fallback for us. And several of the MetaHumans in our project are just doing that. Visual styles. I think a lot of people assume that if you're using a MetaHuman, it's assumed that you want something that's going to be fairly photorealistic. But just a reminder, you can stylize things. And the MetaHuman material, as we'll see in a second, is very complex. So to be able to say, no, we're just going to make it all white or black or slightly transparent or a more reduced version of the basic version of the MetaHuman material is maybe preferable. And in some cases as well, you might find that you can use a much lower quality LOD for a MetaHuman, because as soon as you're at this level of quality, you can probably use LOD 7 or 8, and most people aren't going to notice because you're not seeing the details of the face as much. I also quite like using post-process materials, which allows you to stylize what a scene looks like. And in that case, of course, you can also start to figure out what level of detail for MetaHumans makes sense. So we're going from, a pure white or pure black silhouette to something that maybe starts to feel a little bit more cell shaded in this example. I'm actually just using an out-of-the-box post-process material that comes inside of the ArcViz template, so you can actually find that yourself just by opening that up. Okay, so the other thing that we found with Body of Mine, of course, was that the textures were very, very, very heavy, and the materials were very, very complex. So we tried to find a way, for example, this is the body skin material, to still get something that felt as close to the quality of the MetaHuman material as possible, but we wanted to be able to simplify it as much as we could. Any place we didn't need a texture and we were okay just using a simple float parameter, that was particularly helpful. And then there's a couple other little optimization tips, like in the material expression texture sample, if you make the sampler source shared wrap, that lets your GPU reuse your sample settings, and that actually drastically reduces the memory, and it makes it much more optimized and run much smoother. So here's an example of the shader graph for the MetaHuman material as it started. A lot of shader instructions versus the much more reduced version. And as you can see, pretty comparable, especially if you are not ultra close to the character. And of course, what we're seeing on the right of both of these is the material complexity. Red means bad, green means good. Now you'll notice the eyes and the eyelashes there are still red. It's because the eyes have some translucency. It's because of what's going on with the eyelashes. So there are some additional steps you can take there. In this case, we started looking at ways to eliminate those entirely. For example, if you use a masked material, it doesn't have to be translucent, and you make it 0.5, I think, as the opacity, that will basically make it invisible. And then if you have a bunch of material slots, in this case, we called it M transparent, but it was a masked material, we could go through all these places where you didn't really notice that the material was gone, things like the little tiny hairs on the faces, and you could actually see if it actually made a difference or not. And these were all just further optimizations to everything. And then, yes, I mentioned that if you do want to go much deeper into how you modify the MetaHumans and go into like actually changing the material slots and exactly how detailed the meshes are and all that, we didn't actually do this for this project, but I know that our next step would have been to go into DNA calibration and starting to open up something like Maya to really get into the details of every bone and every polygon of the MetaHumans. One quick thing, just wanted to throw out there. This is something that Epic passed on to me, so I'm just saying, hey, here's a thing that Epic told me is a good set of variables to use when you're rendering MetaHumans out of the movie render queue, just as a starting point. And of course, you can add other CVARs that might be useful if you wanted to do more with like Lumen, for example. So just keep that in mind. And yeah, take a picture if you want. And then I thought I'd cover just a few common issues that I have seen. I've got some videos on YouTube that some of you may have seen about things like the head and the body detaching and stuff like that. Quite a few of those actually have been solved as of 5.4, which is nice. But here's some that I have still run into. One is flickering lumen lights. If you look right under the neck there, we've got a lot of noise. And I found that contact shadow length is something you can do for whatever light is causing the flickering. If you bring up contact shadow, it'll help lumen be much better. So that's a pretty simple one. Why does this happen? Well, this could happen for any number of reasons. And the top ones that I have found is if you're using a version of MetaHumans that doesn't match your current engine version, if you just migrated in a 4.27 MetaHuman into 5.3, and you're still trying to use MetaHuman tools or newer animations, that's one way this can happen. Another way this can happen is if you recorded an animation, maybe with a take recorder or somewhere else, on top of a MetaHuman directly, and you were at a different LOD where the bones are actually different, because the bones do change for the MetaHumans as you go to progressively lower quality LODs. Sometimes the master pose needs to be adjusted. You need to actually assign animations individually to things. I'll mention more about that in a second. Sometimes animation post-process, just enabling it, disabling it, will actually fix this. And also sometimes you'll find that there's actually nothing wrong. I've gone through all these troubleshooting steps, and then I'll just like close my sequencer and open it back up, and it's working again. Or sometimes I need to close the engine, or sometimes I need to restart my computer. But sometimes before you panic when you see something like this, just try restarting, and you might actually find there's nothing wrong. So just to run through these a little bit quick, this is what happened when I brought in a MetaHuman from an earlier version of Unreal and then tried to apply an animation. So this was kind of a version mismatch. And actually, the bridge system for MetaHuman has actually gotten much better now at alerting you to the fact, saying, hey, you've got some older MetaHumans in here. Would you like to upgrade them? And it actually does a pretty great batch process. You used to have to do this more manual thing where it would tell you to like go find the MetaHumans and where Bridge and Quixel stores it, and you needed to migrate it yourself. And now they've made that much, much simpler. So you can basically say, yes, Unreal Engine and Quixel, I would love to upgrade my MetaHumans. And it says, here's the current version, here's the engine version, and then it will go and process them all. As usual, you probably should make a backup there to make sure that nothing terrible happens. Here's what happens when you have the wrong LODs set up. So in this case, there was an animation that was recorded at a different LOD from what's going on here. So you see everything getting wackier and wackier as we zoom out to different LODs. And the only one in this case that was working was LOD 0. So the fix in this case, not ideal, was just to say only use LOD 0. So this would be usually a candidate for like, let's re-record the whole animation. But just as a quick fix, you can see I'm going from the forced LOD being -1 to 0, and now it's working fine. But it is going to be pretty expensive in that case. If you've got some crazy animations happening, especially at the body, one of the main ways that we've been able to solve this has actually been looking at the function that all MetaHumans have called enable master pose. And this is why when you assign an animation to the body, it also works with the feet and the pants and all the other skeletal meshes that are part of the MetaHuman structure, because you have this set leader pose component where you're saying, hey, I want everything to follow the body. Just treat that as the thing that knows what it's doing, and do the same thing. But sometimes you end up in situations where things are detached or going in really wonky directions. And one solution was to actually pull that apart and manually assign the animations to each of those sub-skeletal mesh components, or merge them. Actually, we've actually tried just putting it all together as one skeletal mesh, and that seems to solve it as well. Incompatible skeletons, this is something that I mentioned earlier. Here's the checkbox. You'll also find this anywhere animations are sold. And if you say allow incompatible skeletons, it's a great starting place for seeing if you are able to use skeletons or animations rather, before retargeting them, because they might just work fine. Again, particularly true with the mannequin animations, because they are very, very close to the MetaHuman skeleton. But that can also cause problems. So certainly if you are having issues with an animation, make sure that you are not actually forcing a incompatible animation to work with your skeleton. I think it's good that it's off by default. Okay, wanted to very briefly talk about VR because it's something I like very much, but hopefully this is also useful to folks who are not working in VR. So one thing that we found was that there's a new SDK for Unreal. This is it's not on the Oculus/Meta branch of Unreal Engine. You can actually just use the Meta XR plugin, but it's at Oculus Samples/Unreal-Movement, and this gives you full body tracking. It uses the cameras in the VR headset to actually do something to kind of see what your legs are doing, and it does really excellent IK. You never really end up with a body that is in a position that would be unnatural in nature. So it prioritizes realism over accuracy, and I think that's actually quite okay for a standalone device. So there's two assets that come in with the Meta XR plugin when you open up this project, which can also be migrated. One is a body retarget asset for MetaHumans, one is a face retarget asset for MetaHumans, and then if you're using something like the Quest Pro, you then have the ability to do full body animation just from a headset. You don't even need the controllers because you can get the hand tracking from that. So you now have eye tracking, mouth tracking, hand tracking, and body tracking all from one device. So even if you're not targeting VR as an end goal, consider this as maybe a mocap solution, and I'll show you more about that in a moment. So once you actually open up VR and you're inside Unreal Engine just in VR preview, not even talking about packaging for it yet, you can actually record all this as well. So I'm doing this live in this case. I've got like a little camera switcher that I've set up to gesture, and I've got the eyes, the mouth, and the body all kind of moving here. And I was just kind of testing out how things register and how things don't. And I do like to think of it as puppeteering because it's not always exactly what you think it's going to be. But if you kind of learn, like when I bend my arm like this, the character does this, it feels a little bit like the way you would start to control a character. So here I am opening up the take recorder. I've literally just got my MetaHuman dropped into the take recorder. I go into VR preview. I Alt-Tab back over to here. I press record. It doesn't look like anything's happening in the viewport, but I actually am recording now exactly what I'm doing over in VR preview to sequencer. And so as I do my dances or whatever the case may be, that actually then pops back out as an animation that I can scrub through, and it gets the hand tracking, it gets the face tracking, everything there you would want. So really straightforward mocap solution, all from just a single headset. Maybe worth considering, especially because you can find Quest Pros now used for like, $400. They used to be $1,200, so that's not bad. A few bonus tips, and then we'll try to do a little Q&A. First, again, I'm very jealous of UEFN right now because they have amazing MetaHumans that are 70 megabytes. And if you want to just start playing with your MetaHuman in UEFN, this is not a UEFN talk, but you can go to the MetaHuman importer in UEFN, which is down there, same place you'd add in like new game modes, pulls up the same library you'd have everywhere else. And then again, there's the dropdown I mentioned for highest quality versus lowest quality. But even the highest quality one is still not that big. So once you have your MetaHuman inside UEFN, in this case, there's a template that has like an animation already set up with Fortnite characters. And just like in Unreal, it comes in with a control rig, so you delete that. And then all I had to do was go ahead and tell the MetaHuman animation to use the animation for the Fortnite characters. Didn't have to retarget anything, didn't have to allow incompatible skeletons or anything like that. Basically, it was drag into sequencer, tell it to use the same animation, and then just reposition the MetaHumans to be in the spot that I wanted them to be. So I just kind of love how simple and out of the box that is. And again, 70 megabytes. So someday I hope we're able to bring that back over to Unreal. But for now, I just look at Fortnite and feel very jealous and envious. This is a little bit of what the sequence looks like by default. There, of course, is the mesh to MetaHuman animation that I was just playing with how that felt. And then we're just, popping over to the character. And again, you get everything. You get the face animation, the body animation. It's really cool. I do want to shout this out really quick. I'm sure there have been 10 talks already at Unreal Fest about it, but it is so easy now to retarget animations. Like you say, here's the core skeleton I have. Here's the target one. I do like to do anything with the word preview, by the way, when targeting a skeletal mesh, because it'll show you more of what the MetaHuman skeleton actually looks like, even though the actual name of the MetaHuman skeleton is like base_skell. This is fine. And then, of course, you can grab whatever animations you want there, and they'll be retargeted. It's so simple. And you can go into more detail with like adjusting the retargeting if you want, but I like this quite a bit. Where's some places you can find full body animations? Well, this is a slide that I had for a talk at Unreal Fest in New Orleans last year. And so I'd say, you know, search the Unreal Engine Marketplace, search Mixamo, search Ready Player Me. But of course now, just recently, I think like last week, we have this incredible game animation sample, which has 500 AAA animations. So if you want to play with more than just the idle and jump and the third person animations with your MetaHumans, what a great resource now to play with this and motion matching and all the cool ways you can use MetaHumans. Now, this is a fun one. This used to be much harder. If you were taking the third-person character in Unreal and you wanted to retarget it to work with the MetaHuman, it was like maybe a 15-minute process to do it like properly and have everything working. But there's something now called Live Retarget, which makes this about as simple as it could possibly be. So here we are, third-person template running around, and all I'm going to do is open up the third-person template here. I'm not going to delete anything. I'm not going to pull apart the MetaHuman into its components. I'm just dragging the MetaHuman blueprint up into the project. I'm going to make it a child of the mesh there, not changing anything about it. And I'm going to go over to the viewport. You'll see it's just positioned differently, so I have to reset the location and the rotation. So it's about in the right place, but there's no, it's still in A pose. But I'm going to hit live retarget mode, and it snaps right there to be in the same position. And so already here, it's like, okay, great. We've got the character and the third-person mannequin there working together, but turning off the skeletal mesh, you still need it there for the live retarget if you want to use the same blend spaces and that kind of thing. There's one other thing you need to change for this to work. Type in always tick and change this to, I forget which one, allow tick pose and refresh bones. Otherwise, it actually won't bring the animations correctly. So that's all you need to do now to get a MetaHuman to work with any existing character animation. And it's a little bit like the allow incompatible skeletons things, where like your first step should just be try hitting that live retarget checkbox, and it might work. That's it for now. Thank you very much. We have time for questions.